Whatever happened to predictability? The milkman, the paperboy, evening TV. You miss your old familiar friends, but waiting just around the bend. Everywhere you look, there's a heart, a hand to hold on to. Everywhere you look, there's a face of somebody who needs you. You're lost out there and you're all alone. A light is waiting to carry you home. Everywhere you look.
Gabe, what were you talking about that weapon?
The boom boom.
The boom boom?
Dude, let me show you. To my lab. Alright, ready? Let me draw it out for you.
Okay.
So here's what I'm thinking. So you have the bomb, right?
Yep.
Okay. But what's important is what's going on inside the bomb. Now I'm thinking 2 cores.
Cores. Why?
Okay.
Okay, 2.
Okay, 2 cores.
Why 2?
2 cores. Let me explain that. Because there's 2 parts of a nuclear reaction. There's fission and then there's fusion. So,
What's fission?
let me explain that. Fission is when you take a really heavy atom and you take its nucleus and you split it into 2 or more atoms.
Oh.
So one of the cores will be in charge of that. Let's say it's this core right here. If it's this core, what you have to do is surround it by explosives, chemical explosives, not nuclear explosives.
Alright.
And these chemical explosives, when they detonate, will give enough energy to compress this core. And when you compress a core of unstable material, it will fission. The nuclei inside will split and release more neutrons, which will cause a chain reaction.
Chain
So at the end of the day, all of the material, let's say plutonium in this core, will fission and release a ton of energy. But that's not all. After this, we move to the fusion core. Now the fusion core doesn't need any chemical explosives around it because fusion is triggered by an incredibly high amount of heat and compression. And that heat and compression will come from the fission reaction of the
beautiful.
first core. Now, while this is contributing to the explosion as a whole, its main job is actually to trigger a fusion reaction in the second core. The second core will be another unstable material, uranium for instance, but will also be flooded with hydrogen because hydrogen is a very easy material to fusion. It's very small atoms. So what will happen is the energy from this first part of the reaction will not only contribute to the explosion, but it will also cause the hydrogen and the uranium to become unstable and fusion and release much more energy than the fusion reaction, than the fission reaction by itself.
I see.
And so, with this 2-part bomb, we'll be able to release a ton more energy than we ever would with just 1 core, which is how they used to do it before they realized that by putting a second core in there, the bomb would be much more efficient. Any questions?
So with 2 cores, we can make a bigger boom boom?
That's why the boom is in there twice.
Wow.
That's why they call it.
But Gabe,
Yeah.
what about the strong force in the nucleus?
Well, that's exactly where the neutrons come in.
Oh.
So, especially when we're talking about fission, it's very hard to fission a nucleus because the strong force, like you mentioned, holds it together really tightly. But when we throw extra neutrons in there, right before we detonate the chemical explosives, then those neutrons stick and get absorbed by the nuclei.
I see.
But now the nucleus is too heavy. The strong force can't quite accommodate for that extra neutron.
So
it becomes unstable. And when it becomes unstable, then it splits and releases even more neutrons. And that's what starts the chain reaction.
Because of electrostatic repulsion.
That's exactly
Wow. No way.
Exactly.
That's crazy.
That's why this works, guys. That's why this works.
Oh, all right.
So this is where we put the neutrons for our bomb, and this is where we put the hydrogen. Remember, fusion is hydrogen, fission is neutrons. It's important. Any questions?
Let's do it.
Let's do it.
Let's go.